welcome back. Let's do question 5b. G of x is equal to x cubed minus 3x. We have it there. Then a and b are the turning points of G. We managed to find the coordinates of the turning points in the previous question. And then C, O, and D are the x-intercepts of G. Okay, so now it says, on the Cartesian plane above, sketch the graph of the derivative of G of x. Okay, so we can sketch from this equation because we already have the equation of the derivative of G of x. So let's sketch from this. So what we do, we can find the x-intercepts. X-intercepts, y is equal to 0. So we say 3x squared minus 3 is equal to 0. And then we managed to find this anyway. Right, 3 x minus 1 is equal to 0. X squared minus 1 is equal to 0. Then x minus 1, x plus 1 is equal to 0. Then means x is equal to 1 or x is equal to negative 1. The other thing I would like you to remember is that the x coordinates of the turning points of the original graph are the x coordinates of the x-intercepts of the derivative graph. The x coordinates of the turning points of the original graph are the x coordinates of the x-intercepts of the derivative graph. Remember, the derivative is what? Is the gradient. At the turning point, the gradients are equal to 0. So now if you are drawing the derivative graph, then it will be 0 here on the x-axis. Okay, we can get the x-intercepts without doing this whole thing. Right, now we need the coordinates of the turning point. The coordinates of the turning point we can get from this. Remember, for the equation of the form, g of x is equal to ax squared plus q, the coordinates of the turning point will be 0, q. So in this case, for this one, it means the coordinates of the turning point will be 0, negative 3. So it means it should be somewhere there. The other thing we could have done, you know that the x-coordinate of the point of inflection of the original graph is equal to the x-coordinate of the turning point of the derivative graph. So the point of inflection is here at 0, the midpoint between negative 1 and 1. That's where the point of inflection is, which is 0, meaning that the x-coordinate of the turning point of the derivative graph also is 0. And then you can easily substitute your 0 into this function, and then we're going to get negative 3 for your y-coordinate of the turning point. Now with this, we can sketch our graph. Okay, this is the graph of the derivative of g of x. Done.